So if that's what happens at different a values, let's look at what happens at different b or c values. So to start off with, we'll be looking at different b values. So here I've written a few things out, and now let me draw my axes, x and y, and let's get started. So we know what y equals x squared looks like. I know that here I'm at 4, here I'm at 1, here I'm at 0, again 1, and again 4. We just drew this earlier, so it's not too difficult. So now let's look at this second case, when b is equal to 1. And remember, up here b was 0. So when b is 1, all we're doing is we're moving this axis of symmetry to when x is 1. So originally, for y equals x squared, my axis of symmetry was x equals 0. But now, when b is 1, the axis of symmetry is when x is 1. So we have a new axis of symmetry. So c is still 0, so our vertex is unchanged. It's down here. So remember, we got that point because x is 1 and y is our c value, which is 0. So that's the point 1, 0. And now remember, I didn't change a, so I shouldn't be any narrower or any wider. So this is really just the same thing as I had with y equals x squared, but it's shifted over 1. So I can plot my points here as what they were before, but shifted over 1. And now if I connect these dots, there you have it. Notice that it's shifted to the right when b is positive. But now let's look at b equals 2. It should be shifted to the right one more, and in fact, it is. So we know the vertex is here, and everything is just moved over 1. So I can easily show you what that looks like. And now when b is negative 1, our new axis of symmetry is at negative 1. And so this will be our vertex. And again, a doesn't change, so we're just shifting our original graph over a little bit. And if I connect these dots, there you have it. So changing b shifts things right or left, and a positive b will shift it to the right, a negative b will shift it to the left. Now let's consider different values of c. So here I've picked some simple functions, and we're going to be graphing it. And be sure to label your axes, and let's get started. So we've already drawn y equals x squared, and here I'll just do it again. There's nothing too special about that from this point. So now let's consider, that was when c was equal to 0. What happens when c is equal to 1? Well, the axis of symmetry is unchanged. So we know our x value of the vertex is the same, but the y value is different. The y value is whatever c is. So it was 0 before, and now it's going to be 1. So our new vertex is at 1, as at 0, 1. But now keep in mind, a didn't change, so we aren't going narrower or wider, so it's really just what we had before, but shifted up 1. So now it looks something like this. And keep in mind, because it's shifted up 1, it is strictly greater than everything below it. The red function is greater than the black function for every x and y value. So if I picked some x value, any x value, you know that red has a greater y value at that point than the black one does. And now when c is equal to 2, it's just the same thing. Again, we're just shifting up this vertex, but we're not changing how wide or narrow it is. So we're just moving on up. And again, keep in mind, the blue function is strictly greater than the red or the black function. And now if you look back with what we did in the case of changing b's, we can't say anything like that. Things are shifted from left to right. It's really weird. There are some things that are greater, some things that are less, so it's strange. But when we change the c values, it's easy to say whether something is greater than or less than something else. So now let's try when c is negative 1. Well, we're just moving down that vertex to 0, negative 1. So everything is shifted down. So now, this is what that function looks like. And keep in mind, this is strictly less. It's strictly below the black, the red, or the blue. So all of this can all be really compiled into one really elementary understanding. So if I have, let's say, y equals 1/2 x minus 2 squared plus 3. All this really is taking y equals x squared, shifting it 2 to the right, because b is a positive 2, it's shifting to the right 2, making it wider by a factor of 2, and finally taking that and moving it vertically upward 3 units. Now note here that when I say widen by a factor of 2, I'm saying that we're taking our basic function, or whatever preliminary function it was, in this case it's x minus 2 squared, we're taking that, whatever it may be, attempting to draw it well, and then by widening it a factor of 2, what we mean is we're taking all of these points and moving them down by that factor of 2. This is the same thing as really narrowing by a factor of 1/2. By making it half as narrow, you're really just making it twice as wide. So you should now have a good understanding of how to analyze graphs of quadratic functions, but please look at the examples to learn more and to experience more of how we do these things.